are in lesson 16. We're going to talk about complex fractions first. A complex fraction is just a fraction that has more than one fraction line. So a fraction divided by a fraction, or a fraction with multiple fractions in the denominator or the numerator, anything like that. Any of these examples here, these are complex fractions here because there's more than one division line. So let's just jump right in. We've done these last year. They were, a little much, but we did do them in spring of last year. So let's look and see what we have. 16.1, we have, all right, here's our first fraction line. That's divided by a plus m. M is divided by b plus c over d. So the way that we resolve these is we start with the innermost denominator, which in this case is going to be the one on the bottom. So b plus c over d. Now the way that we would solve this is by finding a common denominator and turning it into one fraction. So we would put this over 1. We have a 1 and a d. So d is going to be our common denominator because 1 times d is going to be d. D times 1 is still going to be d. So we're going to multiply both of these by d over d. And when we do that, we get b over 1 times d over d plus c over d times d over d. All right, so these right here would factor out. So you just end up with bd over d plus c over d. Now that they have the same denominator, we can write that as bd plus c over d. And then we can come over here and replace that. So x over a plus m over bd plus c over d. All right, so it doesn't look like we did a whole heck of a lot, but we really did. We really did. We got rid of that denominator that was here and took away the operation and made it one fraction. So now what we need to do is figure out how to get rid of this complex fraction now that it's in the denominator here. So we're just going to attack this one fraction. We're not going to address a plus just yet, just this one thing here, right? And the reason we didn't do that to our original one is because we just had c over d. There was nothing to attack. It was a simple fraction by itself, so we had to include this. Well, now we have a complex fraction here. We need to address it before we can address the a plus part. So now the way we're going to do this is by using keep it, change it, flip it. So you're either going to do two steps. Find a common denominator, or you're going to keep it, change it, flip it. Those are the two things you're going to do. And you know to use keep it, change it, flip it when you have a value divided by a fraction, right? So that's what we're going to do here is keep it, change it. I'm going to not spell all of this because my handwriting ain't the best in the world. Keep it, change it, flip it. That's what we're going to do. So we're going to say m divided by bd plus c over d. We turn this into a fraction by putting it over 1. We flip this around. M over 1 times d over bd plus c equals md over bd plus c. So that's what we rewrite this as. X divided by a plus md over bd plus c. So now we have a value plus a fraction. So we've simplified a little bit. So what do we do now? Well, because we don't have a number divided by a fraction, we have a number divided by an operation here, which this plus is our operation. So we go back to find the common denominator. When we have an operation, we find the common denominator. So I'm going to erase this part here. And usually we go back and forth between the two things. So now we're going to find a common denominator, and the common denominator here with a plus md over bd plus c, the common denominator is going to be bd plus c. So ultimately all we have to do is multiply this by bd plus c. So a times bd plus c plus md all over bd plus c, right? That is our value here, right? Or our new denominator. So we replace this. Let me move these up a little bit because I'm taking up a little bit of room. Move that up, and I'm going to move this one up. All right, so now we say x all over a times bd plus c plus md over bd plus c. Now we have a number divided by a fraction. So now we can keep it, change it, flip it. So I'm going to erase this one. And I'm going to write it x over 1, because this x is a number, divided by this fraction here, a times bd plus c plus md over bd plus c. Keep it, change it, flip it. X over 1 times bd plus c over a times bd plus c plus md. So now I'm going to scroll up a little bit, give us more room. We have x times bd plus c over a times bd plus c plus md. That's our final answer. We cannot factor out bd plus c because it might be in one term here, but it's not in this term. So we cannot get rid of it. It's a lot. Whenever you have an operation and you want to factor something out, you have to be able to factor it out of every term in the top and the bottom in order to get rid of it, not just one. So this is our final answer. So you can see the steps are what we're used to. We know how to find a common denominator. We know how to keep it, change it, flip it. We just have to know how to apply those things, right? It's not difficult. It's just long. That's the hard part. It's just long. So let's look at 16.2 right here. And you can see my answer here matches this answer here. So it means I did it right. Yay! Let's look at the next one. 16.2. We have a over x squared plus b over x, all divided by m over x squared plus k over xc. So here we have an operation, two fractions with an operation divided by two fractions with an operation. So our first step is going to be finding common denominators on the top and the bottom. So we can turn this into a fraction divided by a fraction, so then we can just keep it, change it, flip it. So I hope you see that in here. So the first thing I'm going to do is find a common denominator for the numerator fractions. So I have an x squared and I have an x. So x squared is going to be my common denominator. So all I need to do is multiply this fraction, top and bottom, by x, and then that's going to give me a plus bx over x squared. And that's the new numerator here. And I got that. Let me show you how I got that. I said b over x times x over x, right? So that gives me a plus bx over x squared. That's my first one. Now I'm going to do my denominator here. So here I have x squared and I have xc. So I'm going to find the common denominator of x squared c. So I need to multiply this fraction by x and this fraction by c. So that's going to be m over x squared times c over c plus k over xc times x over x. And that's going to give me the same denominator for both of those, which would be mc plus kx all over x squared c. And that's what's going to go here. Now that I have a fraction divided by a fraction, I can keep it, change it, flip it. So I'm going to keep the first fraction. I'm going to change the sign of division to multiplication. And then I'm going to flip this fraction. So it's going to be x squared c over mc plus kc. All right, so I am going to rewrite it here. So a plus bx, and I like to put my multiplying factor in front, so I'm going to just write it that way because that's just the way I like to see it. X squared c times a plus bx over, and now I have x squared times mc plus kc. Oh, I'm sorry. I wrote that wrong. This should be an x because it was kx here and I just transposed it incorrectly. So I'm going to correct it here as well and correct it here as well. Otherwise I was going to take out that c also. So that should be x here and x here. Alright, so now I'm going to look and see if there's anything I can factor out while I'm doing this. And there is. I can actually remove this x squared because I have an x squared and an x squared both in my problem. So these go away. That gets factored out. So my answer is going to be c times a, which is going to be ac plus bcx because I'm doing it in alphabetical order. And then this is just what it is, mc plus kx. And that is going to be my final answer. All right. I hope you guys see how that worked for that and that you understand that process. So it's all about what is the format, right? Do I have a complex denominator within a denominator within a denominator? Or do I have operation over operation? And if so, how to resolve that? All right, so let's look at 16b, and that is abstract equations. And we have a bunch of those, right? And in fact, this is an abstract equation that we have worked on up here. We did one of those. So we use the process of multiplying by a well-chosen one to change the form of expression if the expression either is in an equation or is not in the equation. So let's jump into 16.3 to illustrate what that's talking about, because sometimes the language in the book is a little confusing and it's easier when you see it. We're going to solve this, and the well-chosen one that it's talking about we're solving for a different letter within an equation that's already been solved once. So this equation is solved for y right now. But now it wants us to solve for c. That's our well-chosen one. So we don't really have any math to do. It's more about logic and moving these things around and finding the proper operations that will logically do that. So to solve for c, we've got to get c by itself. So our first step is going to be getting a common denominator here. So y is equal to v, and then that is going to be times. This is going to be multiplied by x, and this is going to be multiplied by mc, just like we would if these were prime numbers, right? So this is going to be amc plus bx over mcx, right? Now what we're going to do is we are going to put this over 1, and we are going to multiply this times that. So this is going to be y is equal to v amc plus vbx. Oh, that's funny, we have vbx at our church, over mcx. So now we have solved for y. I've completely distributed this. Now we can start to sort it out. Okay, and we're going to do that by, first of all, getting rid of our denominator. So we're going to multiply both of these by this denominator. And we just have to write mcx times y here. That cancels. So mcxy is equal to vamc plus bbx. Now we can divide both sides by the other factors, mxy, and we get, well, I take that back. Before we do that, let's get all of the c's on one side. So we have another c here. So we have to subtract that from both sides, vamc minus vamc. So we have mcxy minus vamc is equal to vbx. Now we can factor out the c. So we take c and we're going to multiply it times mxy minus vam equals vbx. Now we can divide both sides by the other factors, mxy minus vam, mxy minus vam, and our final answer is going to be c is equal to, because this cancels, vbx divided by mxy minus amv. And I guess technically if I write this in alphabetical order, it would be bvx. And that would be your final solution. So you can see we just kind of use logic to distribute, find a common denominator, distribute as we needed to, and then solve for the specified variable. Those are a little bit fun sometimes. With these, it's really important that whenever you type your answer in, make sure all of the variables are in alphabetical order. I'm going to do my best to, when I type the answer in from the book, make sure that I type them in alphabetical order so that the system can check it and we can get a good answer. So let me clear this. I'm going to go back to the top of the page. And let's look at division of polynomials. So we did this again last year, and in the spring, we're going to divide x cubed minus 2 by x minus 1. So we set this up, x cubed minus 2. We can't have missing exponent, what's the word there? Where it descends, that's the word I was looking for. We can't have those missing descending exponents. So we need to just put them times 0. It doesn't change the value because 0 times x squared is still 0. So it doesn't change the overall value of the statement here. It still ends up being x cubed minus 2. This is still 0, but we have to have a placeholder. Much like whenever you are multiplying and you put zeros in when you move to the next place value over to remind you to start in the next or in the right spot. It's very much the same thing. So x minus 1, you always look at the x. So x times what gives us x squared, or x cubed? That'd be x squared. X squared times x is x cubed. Now we go ahead and carry out that multiplication with our negative 1. So x squared times negative 1 is a negative x squared. Negative 1, right? We subtract, we change the sign so we can subtract just like we do in regular long division. That cancels the x cubed, and that adds a 1x to our 0x, so 1x squared. And I like to, when I'm doing this, I actually, like the book doesn't have it, but I like to put the 1 there just for the visual reminder. It just helps me do a better job, right? So now I look at this and I say x times what gives me x squared? Well, it's a positive number, so it's a positive x. So x plus x. X times x gives me x squared, and x times 1 gives me a positive x. But I'm going to change the sign, or actually this will be a negative x, I'm sorry, because it is a negative 1. So I'm going to change the sign to subtract. That subtracts, that becomes positive. X squared minus x, that cancels. And then I have a 1x here. Bring that down. X times what gives me 1x? Well, that'd be a positive 1. 1 times x is x. 1 times negative 1 is negative 1. I forgot to bring down my negative 2, sorry. So you have to bring that down. I didn't bring down my 0x either. I have to remember to do that. So we change the sign so we can subtract it. That cancels. Negative 2, positive 1 is a negative 1. So our remainder, we just put up here, we make it a negative 1 over x minus 1. And that would be the answer here. All right, so that way the answer to x3 minus 2 over x minus 1, we actually have an answer for that. It's this. We can actually do that math. All right, so if you have any questions about how we resolve all of this, just let me know. Just ask. Ask if you have questions. And then we can target the specific problem or the specific process that either was confusing or didn't make sense. We can go over that. I can send you a personal video for that. So let me know if you have questions so I can help. Ta-ta for now.